A random variable is a variable whose possible values are outcomes of a random phenomena. The random variable can be discrete or continuous. The discrete random variables can take certain values while the continuous random variables can take any value within a range. The most important thing I'll suggest the students is that to understand these distributions and to associate it with examples. That is the best way to understand and explain this concept. So we start off with the discrete random variables. The first one is Bernoulli random variables, which are used to model experiments that have two possible outcomes, 0 or 1. An example would be flipping a biased coin such that the probability of obtaining heads is P. Geometric distribution. Imagine that we are going to take this same biased coin and we flip it until we obtain the head. So the probability of having to flip the coin k times is given by the formula. Binomial random variables are extremely useful in probabilistic modeling. They are used to model the number of positive outcomes of n trial modeled as independent Bernoulli random variables, and it is given by the formula. Next is the Poisson distribution, and it is best understood and explained by an example. Like, a call center wants to model the number of calls they receive over a day in order to decide how many people to hire. And using Poisson distribution, this can be obtained. Next, we move on to continuous random variables. We start off with uniform random variables, which models an experiment in which every outcome is within a continuous interval is equally likely. As a result, the PDF, or the probability density function, is constant over the interval. Exponential random variables, these are often used to model the time that passes until a certain event occurs. An example would be decaying radioactive particles. This is one of the most important and arguably the most important and popular random variable of all the probability and statistics. Yes, it is called the Gaussian or the normal random variable, which is used to model variables with unknown distributions in the natural sciences. This is motivated by the fact that sums of independent random variables often converge to Gaussian distributions, and this phenomena is captured by central limit theorem, which we will explain in the later videos.